This is Honors Pre-Calculus 2013 Final Exam Review. We're looking at question number 30. Question number 29, by the way, is very similar to number 27 and 28. So if you have questions on number 29, you should go back and look at those two. For number 30, it's a little bit different, although it's similar. We're given information that sine of 2 theta is 21/29. They tell us cosine theta is positive, and they ask us to find cosine of 2 theta. And it says use identities to find the indicated value. So since they say they don't say to find an exact value, so theoretically we could use decimals and use inverse sign, but the directions say to use identities. So let's solve this by using identities, and let's get an exact value because I think it would be good to add exact value to these directions, and the exam might do that. I don't know if they do or not. So we're looking at number 30, and number 30 tells us that sine of theta is equal to 21/29, and that cosine of theta, all we know is it's greater than 0, and the important thing to know is that it's positive. And they ask us to find cosine of 2 theta. So we need to know a formula that relates to the cosine of 2 theta. And fortunately we have one, and that's another one that you don't have to memorize because that will be on the formula sheet that you'll get to use. You will have to recognize it. It won't be labeled, but labeling doesn't really help you much anyway. This is cosine of 2 theta equals cosine squared theta minus sine squared theta. So that's what we know that cosine of 2 theta is. And by the way, a little hint for people who are taking calculus next year. This formula is extremely important when you get to BC calculus and you're doing integrals of cosine squared and sine squared. But for now, we're just going to work with this identity. Now, we can find what cosine 2 theta is because we have cosine squared theta and sine squared theta, but just like 27 and 28, we're missing a crucial piece of information because we know that sine of theta is equal to 21/29, so we can plug that in for the sine squared theta, but we don't know what cosine squared theta is. So how are we to find out what cosine of 2 theta is? Well, we need to find out what cosine squared is. So we can do that by the fact that these sine and cosine are related. So we'll try to find this cosine squared theta. We're going to find that by saying sine squared theta plus cosine squared theta equals 1. So sine of theta is given as 21/29, and we have to square that. And then cosine squared theta equals 1. Well, that's a little bit difficult that we have to do 21 squared. I'm not sure I can do that one in my head. So let's just get Mr. Calculator and ask Mr. Calculator, or Ms. Calculator if you have Ms. Calculator. And we'll do, I'm not going to put all this in my calculator and get a decimal because I don't really want that. But what I can do is, what's 21 squared? It's 441. So for my numerator, I'm going to put 441. And what's my denominator? It's 29 squared. So I'm going to go 29 squared, and then my denominator is 841. Or 841 plus cosine squared theta equals 1. Now I'm really interested in what cosine squared theta is, so I'm going to say cosine squared theta equals 1 minus 441 over 841. Now I do need a common denominator for those, and I could go to a calculator to do that, but it's pretty easy when I'm just subtracting from 1 because the common denominator is just the 841. So I really just have 841 over 841 minus 441 over 841, and it doesn't take a supercomputer to figure out that 841 minus 441 is 400. So I have 400 over 841. I could think about whether this reduces in some easy way, but it doesn't seem to, so I'm just going to leave it like that. Now, if I were just interested in cosine of theta, because they told me here cosine of theta is greater than 0, so we could find out what cosine of theta is, I could take the square root of both sides and find that out. But what would be a good thing for us to notice is I'm not interested in what cosine theta is. I'm interested in what cosine squared theta is. And I already know what cosine squared theta is. So what I don't want to do is take the square root of this and then square it again back into the formula. So what I can do instead is say, all right, now I'm really ready to plug back into this formula for cosine of 2 theta. So cosine of 2 theta is equal to my cosine squared theta, which is 400 over 841, minus my sine squared theta, and my sine squared theta I know is 441 over 841. So that equals negative 41 over 841. And that's what the cosine of 2 theta is. Now, there's a thing to sort of notice about this cosine of theta greater than 0. So first of all, it says here that cosine theta is greater than 0, and we got a negative answer. So does that mean that we did the problem wrong? No, because this says that cosine of theta is greater than 0, but that doesn't mean that the cosine of 2 theta should be greater than 0. So the fact that our cosine 2 theta came out negative doesn't really mean anything. Now, if we look at the fact that they gave us this cosine of theta greater than 0, that would have allowed us to find out what the cosine of theta is, whether it's positive or negative. But then when we plug that back into cosine squared theta, we would square it anyway, so it doesn't matter whether cosine theta is positive or negative. So although it was nice for them to tell us cosine theta is greater than 0, and it didn't hurt us for them to do it, we didn't actually need it to answer the question. And so here's what we have. Cosine of 2 theta is negative 41 over 841. And that's how we do number 30. And it looks like if I make a comparison to number 31 and 32, they're very similar. We're asked to find cosine of 2 theta, we're asked to find sine of 2 theta, so we're just going to use different formulas with our different given information.